All right. Time to put those thinking caps on, everybody, because we are diving headfirst into the world of geometry today. Buckle up.
Geometry.
Geometry. We got some textbook excerpts sent in all about parallelograms, triangles, and, that thing they both have in common.
Let me guess. Area.
You got it. Area it is. And before anyone tunes out thinking, been there, done that, back in high school, I got to tell you, this stuff gets surprisingly cool. Like, way more interesting than I ever remembered.
Oh, I agree completely. It's easy to think of these shapes as, simple, basic, but honestly, there's a whole lot of complexity hiding beneath the surface, especially when you start digging into area.
Exactly.
Yeah.
And speaking of digging in, this textbook we got, it starts off simple enough, defining area, just like we all learned it way back when.
Amount of space a shape takes up.
Bingo. Measured in those handy-dandy square units, like square feet, square meters, that sort of thing.
Can't forget those square units. Though, it's important to remember, even though we get caught up in the calculating the area itself, that's real-world stuff.
Oh, absolutely.
Think about it. Measuring for new carpet, you're not just playing with numbers on a page, you're dealing with the actual space you walk on, live in. Makes a difference.
Super important point. Easy to get lost in the formulas and forget area has real consequences. Now, the textbook here, it gets into this whole thing about congruent figures versus just having equal areas, which those aren't the same, are they?
Not at all. Congruent, that's like identical twins in the shape world. Say everything, sides, angles, the whole shebang.
So obviously same area too, right?
Yeah.
Gotta have the same area if they're exactly alike. But here's where it gets tricky. Two shapes, totally different, can still have the same area.
Now hold on a second, really? That seems kind of backwards to me.
It does, doesn't it? But this textbook, it gives a great example. Imagine a farmer, we'll call her Boodia, trying to divide up her land. Use a triangle, see? And she wants to split it equally between your kids. So she figures, easy peasy, just divide one side into equal parts. But here's the thing.
I'm guessing just eyeballing it like that doesn't actually give you equal areas, huh? Poor Boodia.
Exactly. And that right there shows why understanding area, like really getting it, is deeper than just cutting things up visually. It's about the whole relationship between shapes and their properties.
Okay, all right, so let's get into those relationships then. This textbook, it spends a lot of time on parallelograms, specifically the ones that are, and I quote, on the same base and between the same parallels. Honestly, that phrase always makes me kind of dizzy.
Lots of geometry jargon can be like that.
Can you break that down for me?
Sure, picture two lines, perfectly parallel, right? Like train tracks, never crossing. Now, connect those lines with a straight segment that's your base. Any parallelogram you draw using that as one side and making sure its opposite side also fits neatly between those train tracks, well, those fit the description. Sharing that base, same direction, it's like a little neighborhood of parallelograms.
Okay, I'm kind of seeing it. Like they're all lined up on the same street. Right. Street's the base, the buildings are the parallelograms, all going back the same distance because of those parallel lines you mentioned.
Yeah.
So big question is, does this shared setup, does it mean they all have the same area? Even if one's all long and thin, another's squished down low, but they're on that same base and between the lines, same area.
That's the truly fascinating part. They do. It's not just by chance either. It's like a core rule of geometry. No matter how you stretch, how you squish a parallelogram, as long as you keep that base and stay within those parallel lines, area's stuck. Like magic, but with math.
All right, now that is what I call mind-blowing. Okay, so how'd they figure that out? What's the secret behind this area magic?
Well, the textbook, it uses this really clever trick, a visual proof based on something we talked about earlier. Congruent triangles, remember those?
Okay, you got my attention. Tell me more.
So, picture this. You got your parallelogram, right?
Got it.
Draw a line, corner to opposite corner, right through the middle.
Like slicing it in half diagonally.
Boom. You got it. And what have you created?
Two triangles, obviously, but they're not just any triangles, are they? They're like mirror images, right?
Exactly. Congruent triangles, we call them. Same shape, same size, everything matches up.
Okay, so we got matching triangles inside our parallelograms. But how does that prove anything about the whole area thing?
Ah, good point. Well, think back to what we said about congruent figures. Everything means.
Same area.
You got it. So those matching triangles inside. Equal area, guaranteed. Now, what's left of the parallelogram once you take those triangles out?
Another two triangles matching each other.
Bingo. Two sets of identical twins, area-wise, making up our parallelograms. So no matter how stretched out, how squished, if they got that same base and those parallel lines, their areas,
Got to be the same.
you're getting it. It's all about those relationships, you see.
Man, I'm telling you, it makes you realize how much you forget from school. But this is like fun remembering.
Yeah.
Makes sense. Okay, so we cracked the parallelogram code. What about triangles then? They're basically half a parallelogram, if you think about it.
You're on the right track. And this textbook, it agrees with you. A triangle's area is half that of a parallelogram, but, and this is a big but.
There's always a but.
There is. If and only if they share the same base and are between those same parallel lines we keep talking about.
It's all connected. That shared base, parallel lines thing is like the key to the whole area puzzle.
Yeah.
But why is it so important?
Well, think of the base like a starting line. Both shapes line up there, right? So it's how we measure out from, and the parallel lines. They make sure both shapes have the same height. Remember, height's that straight perpendicular distance from the base to the top.
Ah, right. Without the lines keeping things even, the heights could be all over the place.
Exactly. You need that consistency for the area relationship to work out.
Makes total sense. So that triangle formula, half base times height, it's basically just reflecting this whole parallelogram connection, huh?
Hit the nail on the head. Base is our shared starting point. Height's controlled by those parallel lines, making sure everything's nice and even. It's geometry in perfect harmony.
Pretty elegant, I gotta admit. Okay, one more thing from the textbook that caught my eye. It said something about a triangle's median, dividing it into two triangles of equal area. Now remind me, what's a median again?
Oh, right. Median of a triangle, that's the line you get when you start at one corner, one vertex, and draw straight to the midpoint of the opposite side.
Like if you were cutting a pizza slice, but instead of a curve, you went straight down the middle.
Perfect example.
Okay, so the median splits the triangle, sure. But how do we know those two new triangles have equal areas?
Because, my friend, those two smaller triangles, they share a base now.
The median itself.
You got it! And not only that, but guess what? They're also nestled between the same parallel lines.
Wait a minute, so they fulfill that magic if condition.
That's right. Same base, same parallel lines, which means
They gotta have equal areas, just like our parallelograms. It's amazing how it all ties together.
it really is. Geometry, it's all about these connections, these underlying principles.
One thing leads to another. It's like a domino effect. Even the diagonals of a parallelogram, the textbook says, those create 4 equal area triangles when they cross. Suddenly I'm seeing parallelograms and triangles everywhere, and they're not so basic anymore.
That's the beauty of it, isn't it? It's all around us, hidden in plain sight. You just got to know what to look for.
My eyes are definitely open. We've covered a lot of ground today. Area being more than just a formula, that whole connection between parallelograms and triangles, and of course that if condition. Shared base, same parallel lines, equal areas. What are the big takeaways you'd want our listeners to remember?
Well, I think number one has got to be area, it's real. It's not just some number on a page. It's about actual space. And knowing these area relationships, it can really come in handy.
Like when you're a farmer trying to split your land fairly?
Precisely. No more arguments with the kids. Secondly, remember that bond between parallelograms and triangles. If they share that base and got those parallel lines keeping them in line, their areas are linked.
Parallelograms with that setup. Always equal areas no matter how wonky they look. And the triangles. Half the area of their parallelogram buddies.
You got it. But, and I can't stress this enough, that if condition, it's crucial. No shared base, no parallel lines, all those area guarantees, they go right out the window.
Out the window, gone.
And finally, maybe the most important thing to remember is this. All this geometry stuff, it's not just some abstract idea stuck in textbooks. It's everywhere in the real world.
Beyond dividing up pizza, you mean?
Way beyond pizza. Think about architects, engineers, even artists. They're all using these area relationships constantly.
Wow. When you put it that way, it's like a whole new perspective. So, to our amazing listeners out there, we challenge you. Take another look around. See if you can spot these geometric principles at play in your own lives.
You might be surprised what you discover.
And if you do find something cool, be sure to let us know. We love hearing from you. This has been an awesome deep dive into the world of shapes.
It has indeed.
Who knew geometry could be so much fun?
It's been a pleasure exploring it all with you.
Likewise. And to all our listeners, that's a wrap on this episode of The Deep Dive. Keep those brains buzzing, those curiosity muscles flexed, and we'll catch you next time for another fascinating adventure.